Hello everyone, welcome to Coders Camp. We are at 7th day of December LeetCode challenge, and the problem we are going to cover in this video is convert binary number in a linked list to integer. So the input given here is a head of a linked list, and we have only zeros and ones in each node, and we have to return the decimal value of the number in the linked list. So let's understand this with an example. So the problem here can be divided into two parts. First is converting the linked list nodes to a binary number and then converting the binary number to decimal value. So here if you consider the nodes are having the value 110, and if you convert it to a decimal number, then the value is going to be 6, and that is going to be our output. So to convert the linked list to binary number, it is pretty straightforward. So these two problems are separately easy, and if you already know to solve them, it is pretty much easy to solve this problem as well. So starting from the very first node, which is the at pointer head, and iterate it till we reach the pointer null, and at every node what is the value, we can pick that for further calculations. So that is how we iterate and pick the numbers from linked list. So that is the first half of it, and the second half can be solved in two other ways. So the first classical way is to multiplying the values with the power of 2. So starting from 0, the first value will be multiplied with the 2 power 0, and that is going to be 0. And the second value will be multiplied with 2 power 1, and third value will be multiplied with 2 power 2, and so on. So finally the sum is going to be 6, and we are going to return that as our output. So this is pretty simple. We iterate every node and pick the value and multiply it with an extra 2, because the value will be already multiplied to the result. Consider this is our result, and whatever is there we will be multiplying. If it is a 1, we'll be multiplying it with a 2, another 2. So if suppose we have one more 1, then with this we'll be multiplying with 2, and our answer will be at the final sum. So this is going to work in big O of n and big O of 1 time and space complexity, which is pretty much optimal solution, but you can still fasten up this algorithm by using bitwise. The logic is going to be same, but we are going to get the help of bitwise operators to convert the binary number to decimal. So here is a bitwise method. We are going to get the help of the left shift operator in order to construct our binary number from our linked list. So we have used this operator in most of our bitwise videos. So here again, this is going to help us. So if you are not understanding, or if you are not familiar with what is a left shift operator does, then it is a quick overview. So if a binary number is there, left shift operator is going to move the leftmost bit by 1. So if we do left shift 1, then this is gonna become 0010, because it just moved the last bit before one stage and added a 0. So again, if you perform left shift 1, this is going to become 0100, because it has moved this bit to one position, and so on. So we are going to get the help of this operator in order to move the bits we got from our linked list and make a way for a value in our next node in the linked list. So starting from the very first value, our number, we are going to construct our number from the linked list. Our number is going to be 1, as our very first number in the linked list is going to be 1. So moving ahead to the next node, which is again 1. So before adding this 1 to our number, what are we going to do is we are going to perform left shift by 1, because the next number needs some space to fit in. So if we perform left shift by 1, then this number is going to become 0010. So consider this is a binary representation with 0001, and after a left shift, this has become 0010. So now what are we going to do? We are going to add the number which is in the next node with this number. So the next number is 1 again. So what are we going to do? We are going to add this to this number, which is nothing but OR operator. So OR operator will add this bit to this number. So this number is going to become 0011. So we have constructed or took first two numbers and constructed these numbers. So our head has to move to the next node to iterate that value and add it to our number. So before adding this number, we need to make space for the next number to come. We are not sure whether it is 0 or 1. So we are again going to do a left shift by 1. So which means it will become 0110, because these two bits will be moved and one more bit will be added at the end. So after this, we are going to add what is the number in the current head. So the number is 0. So after doing an OR operator with 0, the number remains the same, 0, 1, 1, 0. So finally, if you see, we have constructed our number from the linked list, that is 1, 1, 0. So converting this to integer will actually give you 6. So instead of multiplying each and every value by 2 to the powers of numbers and then getting it finally the output, you can simply construct it with the left shift operator. So basically how your algorithm getting fastened up is multiplication operator operates slower than left shift. So here the left shift helps us to speed up the algorithm with the same time complexity though. So yes, hope you're understanding this solution. Let's go to the code now. So yes, first part is to cover and iterate the linked list and get the number. So let us say our number is equal to head.value because we are going to start our iteration from there, and we are going to iterate till our head meets null. So here we are going to iterate our head till it meets null. So we are going to iterate head is equal to head.next. And finally, our number is going to hold the output we need. So we are going to return our number. So there is a one-line computation we have to do to convert our binary number to decimal. So every time we iterate and pick the number, the first method is multiplying it with 2 with the previous value. So what are we going to do is number is equal to number star 2 plus what is there in the current head. So yes, this is it. Every time we pick the value in the next node and the previous number, whatever is the output, will be multiplied with 2. So let's run and try. Yes, this works. So again, we are going to update the same operation of the single line program to get it done by the bitwise. So as I said, we are going to do a left shift of that number every time and do a OR operation with the next value. So we whatever number is there, we did make a space for the next number and add the next number. So yes, this is it. This will actually move the numbers and add the next value, and finally we'll be returning the integer value of it. So hope you're understanding this. Let's give it a try. Yes, let's submit. Yes, the solution has been accepted and runs in 0 millisecond faster than 100% of the Java solution. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.